Hello friends, let us now begin the partial derivatives. So z is a function of two variable x and y. So now we have the option of finding derivative of z with respect to x or with respect to y also. So the partial derivative of f, so that's why we call the word partial. So partial derivative of fxy with respect to say x at the point x0 y0. This is we write like this del f by del x, and it is at the points x0 y0. This is equal to limit h tends to 0, f of x0 plus h y0 minus f of x0 y0 divided by h, provided this limit exists. So the change is only in x and there is no change in y. So this is called the partial derivative of f with respect to x. We can denote this as like this, f of fx. We can also say del f by del x. We can also write like z suffix x, or we can write del z by del x also. So in other words, if we take the partial derivative with respect to x, there is no change in y. So then we can consider that treat when you take the derivative with respect to x, then treat y as constant. Same way, we can find the derivative with respect to y also. Then there is no change in x. So we can write like it is fy zy or del z by del y. So then treat x as constant. So let us take some examples. Find the value of del z by del f by del x and del f by del y at the point 4 minus pi if f of xy equal to x square plus 3xy plus y minus 1. So f of xy equal to x square plus 3xy plus y minus 1. Del f by del x is derivative of x square with respect to x is 2x. Derivative of 3xy with respect to x. So 3 and y constant. Derivative of x is 1. Derivative of y is 0 because we are taking derivative with respect to x. So we treat y as constant. And derivative of 1 is also 0. So we have 2x plus 3y. And its value at 4 minus pi is 3 into 4, 2 into 4 plus 3 into minus pi. So that is nothing but minus 7. Same way, we find del f by del y. So derivative of x square is 0. With respect to y, we are taking derivative. So x, we treat x as constant. 3x and derivative of y is 1. Y derivative of y is also 1 here. And derivative of minus 1. So that is 0. So we have 3x plus 1. So del f by del y at the point 4 minus pi is 3 into 4 plus 1. So that is nothing but 3. Next, let us take fxy equal to y times sine of xy. So we find del f by del x, we find del f by del y. So f of xy equal to y times sine xy. Now del f by del x, so derivative of f with respect to x, y constant, derivative of sine, so that is cosine xy, and derivative of xy with respect to x is y, because derivative of x is 1 and y is constant. So this is y square cosine xy. Del f by del y. So we have y here as well as here. So then here we need to take the product rule. So derivative of y is 1. We keep sine xy as it is, plus y as it is. Derivative of sine xy is cosine xy, and derivative of xy with respect to y is x. So this is nothing but sine xy plus xy into cosine xy. Next, f of xy equal to 2y over y plus cosine x. So find fx, fy. So f of xy equal to 2y over y plus cosine x. Now fx, that means derivative with respect to x, and derivative with respect to x, so this 2y is constant. So it is of the form only this. So it is 1 over y plus cosine x. So that is minus 1 over y plus cosine x square, and the derivative of y plus cosine x is 0 minus sine x. So this is equal to minus 2y minus and minus plus. So that is 2y sine x over y plus cosine x and its square. Now we take with respect to y. So y is here as well as here, numerator as well as denominator. So we use the quotient rule. That is y plus cosine x square, y plus cosine x into derivative of 2y is 2, minus 2y as it is. Derivative of y plus cosine x with respect to y is 1 plus 0. So that is 1. Derivative of cosine x is 0 because with respect to y. So this is a cosine x 2 over y plus cosine x and square. That is the answer. Next, let us take f of xyz equal to x into sine of y plus 3z. Find del f by del x, del f by del y, del f by del z. F of xyz equal to x times sine of y plus 3z. Del f by del x, partial derivative with respect to x. So we have two functions. So product of two functions. So derivative of x is 1. Keep sine of y plus 3. No, here there is no x. So the answer is derivative of x is 1. Sine y plus 3z, there is no x. So it keeps as it is. So it is sine of y plus 3z. So sine of y plus 3z. Del f by del y, x constant. Derivative of sine is cosine y plus 3z. And derivative of y plus 3z with respect to y is 1. Del f by del z, x cosine y plus 3z, and derivative of y plus 3z with respect to z is 3. Um, Next example, if resistors R1, R2, and R3 ohms are connected in parallel to make an R ohm resistor. The value of R is in the form of equation 1 over R equal to 1 over R1 plus 1 over R2 plus 1 over R3. Find del R by del R2 if R1 equal to 30, R2 equal to 45, R3 equal to 90 ohms. Now here we have 1 over R equal to 1 over R1 plus 1 over R2 plus 1 over R3. Now del by del R2 of 1 over R equal to del by del R2 of 1 over R1 plus 1 over R2 plus 1 over R3. Now derivative of 1 over R with respect to R2. So first we take derivative with respect to R, that is minus 1 over R square, and derivative of R with respect to R2. So into del R by del R2. And here R1 and R3 is constant. So minus 1 upon R2 square. So del R by del R2 equal to R by R2 square. Now R1 equal to 30, R2 equal to 45, R3 equal to 90 ohms. 1 over R is 1 over R1, so 1 over 30, plus 1 over R2, 1 over 45, plus 1 over R3, 1 over 90. So this is nothing but 1 by 15. And so R is 15. So therefore, del R by del R2 is equal to 15 by 45, and it's square from here. So it is nothing but 1 by 9. Okay, thank you.